In this video, we are going to discuss measures of position. So for our objectives, we have, for number 1, define measures of position, and number 2, identify examples of measure of position. So let's define measure of position. Measures of position show the position of a data relative to the whole data set. So it shows the position of a data relative to the whole data set. It is a number that tells where the scores stand relative to the others in a set of ranked data. So examples of measures of position are the quartiles, the deciles, and the percentiles. Quartiles, deciles, and percentiles are examples of fractiles, which partition data into approximately equal parts. Take note that median is both a measure of central tendency and measure of position. So let's start discussing quartiles of ungrouped data. So for our objectives, we have number 1, illustrate quartiles. Number 2, calculate a specified quartile of a set of data. Number 3, interpret a quartile. And number 4, solve problems involving quartiles. So what do we mean by quartiles? Just as the median divides the data into 2 equal parts, the 3 quartiles denoted by Q sub 1, Q sub 2, and Q sub 3 divide the rank scores into 4 equal parts. So scores are ranked when they are arranged in order. So we have here 4 equal parts, 1, 2, 3, and 4. So this is our Q sub 1, or our first quartile. This is our Q sub 2, or our second quartile. And this is our Q sub 3, or our third quartile. So this Q sub 1 here, or the first quartile, separates the bottom 25% of the rank scores from the top 75%. So this Q sub 2 here, or the second quartile, is the median. And Q sub 3 separates the top 25% from the bottom 75%. So to be more precise, at least 25% of the data will be less than or equal to Q sub 1, and at least 75% will be greater than or equal to Q sub 1. Or at least 75% of the data will be less than or equal to Q sub 3, while at least 25% will be equal to or greater than Q sub 3. So we have here the interquartile range. So what do we mean by interquartile range, or IQR? So it is the difference between the third and the first quartiles. So denoted by IQR is equal to the third quartile, or Q sub 3, minus Q sub 1, or the first quartile. So this IQR is a measure of variability which is not sensitive to extremely high or extremely low scores. It tells us how far apart the first and the third quartile are, and it indicates how spread out the middle 50% of the set of data. So that's IQR. So these are the steps in finding the quartile of ungrouped data using linear interpolation. So for the first step, we are going to arrange the scores in ascending order. Second, locate the position of the score in the distribution. So we have here a formula. So the position of the quartile is equal to Kn over 4 plus 1 half, where K is equal to 1 if you are looking for the first quartile, 2 if you are looking for the second quartile, and your K is equal to 3 if you are looking for the third quartile. And N here is the number of scores. And the last, interpolate the value. So later you will see the steps on how you are going to interpolate value. So let us have example 1. The following data list the amount of time in hours spent by students in answering their modules in 1 week. Find the first quartile or the Q sub 1, the second quartile or the Q sub 2, and the third quartile Q sub 3 of the given data: 22, 20, 27, 14, 12, 9, 27, 4, 13, 28, 17, 37, 16, 7, 11, and 13. So to find the first quartile or the Q sub 1, first, arrange the scores in ascending order. So from this to this. So this is already arranged in ascending order. So next, locate the position of the score in the distribution. So we will use this formula. Q sub 1 is equal to n over 4 plus 1 half. So our k here will be just 1. That's why it is n over 4 plus 1 half. So our n here is 16 since the number of scores here are 16. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So from this formula, n over 4 plus 1 half, substitute the value of n, which is 16, so that 16 over 4 plus 1 half, which is equal to 4.5. So now interpolate the value. So these are the steps of interpolation. First, subtract the fourth data from the fifth data. It's because using the formula, Q sub k is equal to 4n over 4 plus 1 half. And we substitute there the value of k is equal to 1 and n equal to 16, and we get 4.5, and 4.5 is in between fourth and fifth data. So we are going here to subtract the fourth data from the fifth data. So the fourth data is 11. So we will subtract 11 from 12. So that's 12 minus 11 is equal to 1. Next, multiply the result, which is 1, by the decimal part obtained in a step 2 position of Q sub 1. So there we have 4.5. So the decimal part is 0.5. Therefore, here the result is 1 times the decimal part 0.5 is just equal to 0.5. And for the final step, add the result in step B, which is 0.5 to the fourth data or the smaller value, which is 11. Okay, that is 11 plus 0.5, that is 11.5. Therefore, our Q sub 1 or our first quartile is equal to 11.5. So since our first quartile is equal to 11.5, so how do we interpret it? So that is 25% of the students spent at most 11.5 hours answering their module in 1 week, or 75% of the students spent at least 11.5 hours in answering their module in 1 week. So next, to find the second quartile or the Q sub 2, first, Arrange the scores in ascending order. So this is already in ascending order. Next, locate the position of the score in distribution. So that is, using this formula, the position of the Q sub 2 or the second quartile is equal to 2n over 4 plus 1 over 2. So our k here is 2 since we are looking for the second quartile. So that is just 1/2 times the quantity of n plus 1. So here in finding the position of the quartile 2, that is 1/2 times n plus 1 is equal to 1/2 times 16, since the numbers of score here is 16 and plus 1, and that is 8.5. Okay, you just have to substitute the value of k, which is equal to 2, and the value of n, which is equal to 16, and you will get 8.5 using this formula. So next, interpolate the value. So these are the steps of interpolation. So since using the formula in finding the position of the second quartile, we obtained 8.5, and 8.5 is in between 8 and 9. Here we are going to subtract the 8 data from the 9th data. So that is 16 minus 4 is equal to 2. So next we are going to multiply the result 2 by the decimal part obtained in the step 2, and that is 0.5. So that's 2 times 0.5 is equal to 1. And finally, add the result in step B, which is 1, to the 8th data or the smaller value, which is 14. So that is 14 plus 1 is equal to 15. Therefore, our Q sub 2 or the median is equal to 15. So here, notice that the median is the average of the two middle scores since n is even. So now let's find the third quartile or the Q sub 3. So first, arrange the scores in ascending order. So these scores here are already arranged in ascending order. Next, locate the position of the score in distribution. So using this formula, our k here is equal to 3 since we are looking for the third quartile. Therefore, Q sub 3 is equal to 3n over 4 plus 1/2. And the position of quartile 3 is equal to 3n over 4 plus 1/2 is equal to 3 times 16, since our scores here, or the number of scores, is 16. So over 4 plus 1/2. And that is, this one is 12 plus 0.5, so that is 12.5. And now, interpolate the value. So these are the steps of interpolation. So since using the formula in finding the position of the third quartile, we obtained 12.5, and 12.5 is in between 12 and 13. So we are going to subtract the 12th data from the 13th data, and that is 27 minus 22 is equal to 5. So here we have 5. We need to multiply this result 5 by the decimal part of the 12.5. So the result we obtained in step 2, or the position of Q sub 3. So here, 5 times the decimal part of 12.5, that is 0.5, that is 2.5. So 5 times 0.5 is equal to 2.5. Add the result in step B, 2.5, to the 12th data or the smaller value, that is 22. So 22 plus 2.5, that is 24.5. So here, therefore, the third quartile is equal to 24.5. So how do we interpret it? So that is 75% of the students spent at most 24.5 hours answering their module in 1 week, or 25% of the students spent at least 24.5 hours in answering their module in one week. So in this lesson about quartiles of ungrouped data, you are going to answer activity 6B.4, which quarter do you belong?